This video is a preview video for solving absolute value equations. Recall that the absolute value is a number's distance from 0. So the absolute value of 3 is 3, and the absolute value of negative 3 is also 3. So if we're given an equation such as the absolute value of x equals 9, then we know that two values make this true. The values are 9 and negative 9. In both cases, their absolute values are 9. If we have an equation like 2x plus 1 equals 9, there are two values that make that true as well. We have 4 and we have negative 5. If we plug in 4, we have 2 times 4, which is 8 plus 1 equals 9, and the absolute value of 9 is 9. If we plug in negative 5, we have 2 times negative 5, which is negative 10, plus 1, which is negative 9, and the absolute value of negative 9 is also 9. But let's see how to actually solve this. The rule is that if the absolute value of a equals b, then either a equals b or negative a must equal b. And we saw that with numbers before. This is only true when b is greater than 0 because an absolute value cannot be negative. To solve an equation like we saw before, we need to set up two cases. We need the case a equals b and the case negative a equals b. What I mean by a equals b is whatever is inside of the absolute value stays as is, and negative a equals b means that you're distributing a negative to the whole expression inside of the absolute value, and then solving. When I solve these two equations, I get the solution x equals 4 and x equals negative 5. And we have to check both, which we already did on the previous slide, so we know that both of these are solutions. X equals 4 or negative 5. And in this kind of problem, we would have to write both solutions. Absolute value equations can get tricky because we can run into extraneous solutions. These are solutions that we get by solving using the correct procedure, but they are not actually solutions and do not work when checked in the original equation. Look at this equation. The absolute value of 2x plus 1 equals 4x plus 11. I'll set up my two cases and I'll solve. It appears as though the solutions are negative 5 and negative 2. However, if I actually substitute these back in, only one of them comes out true. When we check our solutions, we see that the solution negative 5 does not make a true statement, and the solution negative 2 does make a true statement. Therefore, our solution overall for this problem is just x equals negative 2. Checking is no longer for peace of mind and now is required in order to identify the correct solution to the problem. I hope you enjoyed this video and that it helped you get a brief introduction to solving absolute value equations.